Hello everyone, welcome back again. In this lesson, we'll be discussing exponential smoothing, the next model. Before this, we have discussed near forecasting, moving average, and certain variations in moving average model, which is weighted average, 3 months moving average, 4 month moving average, on an average moving forecast. Let us discuss exponential smoothing method. Let me take all of you to my Excel, and yeah, here it is. So again, we have plotted a monthly sales data, actual demand what we have, and we'll be forecasting with the help of the exponential smoothing method. So I'll be showing also to all of you how you can do it in the Excel. Now what's the connecting link between the average moving average and the exponential smoothing method? If you remember, the one of the drawbacks of moving average uh, forecasting method was that it gave the equal weightage to all the previous observations. It would be average of past 3 months if it's in 3 months moving average. But we discussed that it's a flat historical weighing or equal weightage to all the periods. But the nearest demands should have the high weightage because it's more near term, and the near term future is going to be more closer to the near term past, right? So that's one of the principle in forecasting. Near term future is more closer to the near term past. So we should be giving more weightage to the near term past than to near more far away into the past. So that was one of the drawback. It could give equal weightage since it's averaging it out. But the exponential smoothing is method is going to overcome that method. So we'll see how that's happening. Let's start with the formula. The formula is the forecast of current month is going to be alpha, which is also called as uh, smoothing parameter or learning rate of this equation. The forecast is equal to alpha into previous month demand plus 1 minus alpha into previous month's forecast. So let's start this bit by bit. So let us start with first declaring an alpha. So let's assume we take an alpha is equal to 0.4. How much it should be taken, how it affects the values when it's taken on the lower side of between 0 to 1 or higher side of 0 to 1, that we'll be discussing soon. So for now, just for an example, we are taking 0.4 as an alpha as in 0.4 to calculate our forecast. That's for the formula. It should be alpha into the previous month demand, so which is 42, plus we need to take 1 minus alpha, which is 1 minus alpha into the previous month forecast, which is this. So here in this case, you see we don't have forecast for the previous month, right? So here we need to do initialization of the model. We need to put some forecast. So there are different ways people follow. One of the simplest way is to take the demand is equal to forecast, which is 42. Now we see the forecast comes out to be 42 here. Okay, now we'll freeze the alpha here in the formula, since we'll be dragging it down. If you take this, drag it here, and you will find out different. Let me just again reduce the decimal so that it looks clean and easy to understand. Here it is, different formulas. So let me speak a bit more about initialization. So there are different ways which people follow. One of this, taking demand is equal to forecast. What some also try to do, they try to take the average of this and put it here. But we need to understand one thing. We need to understand that while initializing the forecast, if you give the details of future demand, then it's called as data leakage, which should not be given. The forecast shouldn't be given the future details while it's forecasting, right? Then we have more accurate model, and then it would be a more right way to judge the forecasting model. So data leakage shouldn't be happening. So this is one of the ways, taking the demand is equal to forecast, just to initialize it, and you take this. Now if you see the formula, analyze it deeply. Now considering the March one, now this depends upon of these two parameters. It depends now March forecast is depending upon Feb Feb demand and Feb forecast. And if you go down into the April depends upon March demand and forecast. Coming down, May depends upon April's demand and forecast. So every current month forecast is depending upon the previous month's uh, demand and forecast, and that previous month's forecast, which is this, is dependent upon its previous month's forecast and demand. So if you see, this is going, these two are going input to this, these two are going input to this, these two are going to input this, and inputs for everything, inputs of all the previous forecast is going to the future forecast. So the model is learning from all the data points of the history. That's the beauty of exponential smoothing method. The model learns from all the historical uh, data sets we have, forecasts we have, and it gives exponential weightage to each one of them, and it will give highest weightage to the near term one. Highest weightage will be given to the near term demand and forecast, and a little less to the previous one, a little less to the previous one, and it goes on decreasing like this. So that's how the exponential smoothing work. You can some books you can go into the detail of derivation of the exponential smoothing method. That will give you more understanding how it's exponentially giving the weightage to all the previous forecast and demand. So that means that it's slightly more smarter as compared to the moving average method. So let us discuss some points which I have jotted down to share with all of you regarding the exponential smoothing. First thing, that the model will learn a bit from the most recent observation and a bit from the last forecast. As we saw the formula, it takes alpha times of actual demand 1 minus alpha times of forecast. Now depending upon the alpha value, it will give the value upon more, it will rely more, or it will learn more from demand, or it will learn from the forecast. So that call you have to take. Second is, it's less prone to outliers and noise as compared to the naive forecasting method, and it gives exponential weightage to the recent past. Yeah, just now we discussed that it gives exponential weightage to the recent past. Alpha is smoothing parameter or learning rate. Higher the alpha, it faster learning or reactive. So if you give high value to alpha, since alpha is getting multiplied to demand, if you give high value to it, it will capture more from the recent demand and the trends and the how the actual sales is going on. It will capture more from it, but since the alpha value is high, it will also be prone to more outliers and noise, right? If you reduce the value of alpha, so when the value of alpha is reduced, this term in overall will increase, and it will give more weightage to the forecast. So the more weightage is given to the forecast, it smooth out the outliers and the noise into the data set, and the con would be that it will be slow to pick up the trend. So we'll be discussing this in my next sheet. I have taken different sets of examples of different values of alpha and how the forecast comes for different values of alpha. Seventh is the need for initialization. Yeah, so in this method you need to initialize it. So one of the simplest method we discussed, just to equal it with the demand. Don't give any future data inputs in terms of averaging it and putting it here. That will lead to data leakage. Then one thing we need to understand, that alpha value should ideally lie between 0.05 to 0.5, And another drawback of this is exponential smoothing. Again, it doesn't capture the trend like the previous methods we discussed. Then name forecasting and moving average, it's really bad at picking up the trend. So yeah, so this is what it was, the exponential smoothing method. So let me just also take you to the my next sheet where I have plotted different values of alpha and how. Let me just take the formula also here, it will give you more understanding. So it may be a little difficult for you to understand in the first attempt if you're seeing it for the first time, but just take the data set, take different values of alpha, try to follow my video, and try to do it with the Excel. Make your hand dirty, and with that you will get more grasp on this model, or understand, or you get the more feeling of the model, how the model works. So talking about different values of alpha, so what value of alpha we should take. So if you see, for forecast 1 has alpha as zero point 0.2, forecast 1 as zero point 0.2, forecast 2 as zero point 0.5, forecast 3 as 0.7. There are different values of alpha. And alpha, as you see, alpha will be first multiplied with the demand, previous month demand, previous period demand, into 1 minus alpha of previous month forecast. So just to take an example, if we take this one, so this month forecast is alpha into previous month sales or previous month demand plus 1 minus alpha into the previous month forecast. Now here are the three forecasts, forecast 1, 2, 3, and it has increasing order of alpha. Now blue one is the actual sales value, and the orange one is the forecast one, gray one is the forecast 2, and the yellow one is the forecast 3. And as you see, as the alpha is increasing, the model is faster in capturing the trend is the increasing average, sales increasing in long term. So that's what the trend is. Average increasing the demand is the trend over the period of time. So if you see, alpha, the orange one has the least um, alpha, which is zero point 0.2, the gray one has zero point 0.5, and the 3 has zero point 0.7, the third one, which is the yellow one. Now the yellow one, you see, it's capturing the trend the fastest. And second we have the gray, and orange one is the least or the slowest. But if you also see the plus point with the orange one, is it's not getting affected by the outliers. Let us assume these are the outliers, it's not getting much affected. But on the other hand, if you see the gray one, which is capturing the trend faster, but at the same time it's also prone to get affected by the noise, and the outliers, or consider them as a pattern. And if you see the gray, it's something in between. So we need to wisely choose depending upon our requirement, the value of alpha. Of course there is different uh, ways to optimize it also. In Excel, also in the Python, you put it, and the Excel can calculate for you the best fit alpha value for the model. Yeah, so that's it what I had for this exponential smoothing. Thank you. And